So, all right. I think we have websequencediagrams.com open. This will probably become way too messy to write on the smartboard using my writing skills at least. So I will be using this. It's quite good. You can do most things that you would like to do. You can have like alternative flows. You can have loops and stuff like that. So it's quite nice. There are some features that are only available in premium, but I think you could probably get by. Good tool support for sequence diagrams is hard to get by. Often it's quite messy in WYSIWYG editors. So I actually prefer these where you write some kind of a small syntax and then the view is generated. But you can probably find some good stuff to do your sequence diagrams. So let's get back to the requirement. What is the first thing that actually happens here in this requirement? Well, if we go back, it's actually a signal that the player wants to play the game and that he wants to start a new game. So what is this then? Well, it's a system event. And how should we handle system events? We should use the controller pattern. And we have already done this actually. So the responsibility should be inside the controller to handle the event, and our convention is to ask the view if the event has happened. So let's just continue that. However, as we are using a console for view, we cannot really do it in this way, because then we would need to kind of like ask the user, do you want to quit? Yes or no. Do you want to start a new game? Yes or no. Do you want to hit? Yes or no. Do you want to stand? Yes or no. And that will become a little bit messy. So we need to change this a little bit. And there are some ways to do it. Usually I create an enumeration inside the view that represent all the types of system events that can happen. And you have kind of like one function that you ask, get the system event. And it returns one value from this enumeration. I think this time I will do it a little bit differently by just asking the view to collect the system events, and then we can have these wants to quit, wants to start new game functions instead. You can also solve this by using a kind of like observer pattern construct. That is, you send some kind of listener into the view, and the view can then call this listener with different functions. And this interface will probably be implemented by the controller. So you have a little bit of different options here, and depending on the actual technology used, you can have you can do it in a little bit different way. Maybe the observer kind of like solution is the most advanced, but it also gives probably the easiest way to try to reuse your controllers, because you can probably have a graphical user interface to manage these kinds of events that happens. But and you can watch this implementation with enumeration and so on and so forth if you look at previous year's lectures. But basically what we would like to do is to ask the view, after we have Well, the program calls the controller play game, and then present instruction is called, and then we ask to the view to collect its events, and then we can ask the view if the user has selected to start a new game. And as we can see, we already have all these classes in place, and well, it's just a matter of implementation. So let's do it. What did we call it? Collect. So something like that. Let's just compile, see if we can do the same thing as we had before. Oops, something is not right. Yeah, I think we forgot to. I think we forgot to collect the events. All right, so now we have it. So of course I can't do anything but quit. So the next event to handle is then oh, we didn't implement that one. All right. So maybe we should just add some kind of a small debug printout so that we know that everything is working. So and we got the start new game there. So it seems like we have fixed the first responsibility of handling the system event of starting a new game. So next step. All right, we should take the top card from the deck. We should show it and give it to the player. All right, the first thing is to get the top card from the deck. How should we assign this responsibility? Do we have anyone that knows about the deck already? The dealer, exactly. So let's take a look at the dealer. The dealer has the deck. So the gist of it would be to add this deck handling stuff to the dealer. And if we take a look at the requirement once more, this kind of like is repeated 4 times, and the dealer takes something from the deck and gives it to himself or to the player. So maybe this whole start new game scenario, at least these steps, 1, 2, 3, and 4 should be assigned to the dealer, as it is always about taking a card from the deck and doing something with it. So let's just add that responsibility to the dealer for now. Let's call it start game. And we should have a card C, deck, and I think we already have this. No, we don't. We have a get random card, but that should not be it. I'm suspecting that there is some special operation to get the first card actually from a linked list, so maybe we should use that instead, but let's do it like this for now, and I can look that up a little bit later. So dealer, start new game, deck, get top card. And yeah, let's freeze there for a moment. So, all right, we can get the top card. Now we should show the card, and then we should give it to the player. All right, okay, showing the card implies that somewhere a card can be hidden. So we need to know what cards are hidden and what cards are not hidden. So where should we put the responsibility of knowing if a card is hidden or not? This is something that is an information requirement. For each and every card, we need to know, is this card hidden or is it not hidden? Who should know if a card is hidden or not? The card itself. That is probably a good idea, because this is some information token that we need to add to each and every card, and as also stated here in the chat, inside the card class is the natural place to put this. It's a piece of information, a trait or a state of each and every card, and putting it inside this card class then is probably a good idea. We could have other solutions, of course. We could have an array or something like that in the deck. So you could ask the deck, is this card hidden or not? We could use some other kind of wonky situation, but actually it mimics reality quite well. Either the card has the face value up or it has its backside up. So this is definitely something that we should add into the card. So we could just do this. Then. And let's get back to our small sequence diagram. We had one note here from the chat that shouldn't the dealer be in controller? And exactly, we need some way for the controller now that has gotten the system event to tell the dealer, well, now you should start a new game. So we need some form of way to do this. Not semicolon. We need to do this call, of course, and it's the controller that has kind of like the focus. It knows that, well, we called the user indicated that he wanted to start a new game, and we need to tell this to something in the model so that stuff can happen. So the controller here needs access to the dealer, and let's just send it in for now, since we already have the dealer outside in the, I don't know why I copy pasted that. Start again. So something like this is needed, and we need to send the dealer also into the controller so that the controller can work with it. And now we have the dealer that is doing stuff, and it's doing this, and we are back to the card. So we agreed add this state to the card. So what should happen if we try to get the color and get the value of a hidden card? So should we be able to call these get color or get value if a card is hidden? No? Why? We could just add is hidden operation, and everyone that needs to kind of like care if a card is hidden or not could just call this function and okay, the card is hidden, so I should not ask for color or value. That could be one way to solve things. Actually, I prefer the idea that color and value are not available at all if the card is hidden, because, well, you will probably forget to call this is hidden stuff somewhere if you need to do it a lot of times. So adding a new function to the interface of the card to handle this is probably not a good idea, I think. So should we throw an exception? Yay! We could do that, or we could just accept that, well, maybe it's a special kind of color and value if the card is hidden. So I think in this case we can just add this. Hidden. Hidden. So if So, if the card is hidden and you ask for the color or the value, you just get a hidden value back. I think this is quite good. One drawback is that if you don't take care, you can create a card that has the color hidden and the value hidden also as its actual colors and value. But if you look in a magic box, there are cards that look like this also. So, but probably you should maybe throw an exception in the constructor here if hidden and hidden are sent in. But we will leave that for now. All right. Let's get back to our sequence diagram. So we have this. We are in the dealer. And it will call model deck mdeck get top card. That was it, wasn't it? And it should show the card. card C show get top card, and we get a card, and then we show it. So dealer show. Next step in the requirement is to show it. That is done, and then we should give it to the player. All right. So the dealer needs to give cards to some kind of player, and the player needs to remember the cards that it has gotten so that we can calculate the scores of the player and the dealer hands respectively. And finally, in step 5, we should also display these hands. So how should we solve this responsibility? Who should take care of the player's hand? The player. I could agree with that. Because we have our domain model, we clearly have a concept player. So adding this conceptual class also in the design is probably a good idea. We already have the dealer. And we can see here that, well, the player plays against the dealer or vice versa. And, well, adding this to the design is mimicking the domain model quite clearly. So let's do that. Let's call it deal card maybe. So we give it to the player. And this operation, sequence of stuff, is kind of like repeated 4 times. So, but this time the dealer gives the card to itself. And once more to the player, and finally we remove the last show card there. So this is what we are to implement. Then the first 4 steps are done. So code. And in the implementation, we have the problem that we don't have a player. So we need to create that one first. Too many computers. There we have it. And the player class should, of course, be in the model. So player is created. Should we have this deal card, or what did we name it? Something like that. Next step is to, how does the dealer know about the player? We need a player object here to be able to give the card to the player. Any ideas? Well, we could create a player object here. Would that be a good idea? No, it would probably not be, because we will have hit or something like that here also, and stand, and well, it needs to be the same object, so we could add it as a member. I'm not really comfortable with that either, because, well, the dealer kind of like does not contain a player. It plays against and uses a player, so as stated in the chat here, just send it in as an argument. So then we need to send it in as an argument, and we probably need to have it as an argument here also. A little bit messy, but let's go for this for now. And we can also, maybe if we look a little bit ahead, we can see that, well, we need to know the hand of the dealer and the player, and give this in some form to the view, so that the view later can display the hands of the dealer and the player. So we need the player in the controller anyway. This adds a dependency, exactly. So, and this means also that we need to create this player when we start the game. Oh, did I just wrong there? And we also need to supply the player there, of course. Oh. Now let's do it like this. The player will be named player P, and the controller player will be named C for controller. All right. So stuff is at least compiling. We still have some stuff to do here. We need now to, well, basically do the same thing again. But this time the card should not be dealt to the dealer, but to the player, but to the dealer itself. And we don't need this one. that, and we also should kind of like add the hand of the dealer should also be available. So, all right. I think you can see that this kind of like code inside start game very, very much mimics what we have here. It's almost exactly the same. So this is basically what the sequence diagram is. It's step by step goes through the code and the calls of the code. It's always a matter of detail. How detailed do you want to be? My rule of thumb is, well, I add calls that are calls to classes that I implement myself. So stuff that is actually inside our project, well, that is added to the sequence diagram. So I do not add in the linked list class call here, for example. So that is where I draw my line. I don't go further into basic libraries and stuff like this. And basically this is done. The next step is to calculate the scores and to show the hands of the dealer and player. So we need some kind of access to the hands and well, the responsibility of displaying the hands and the scores should be in the view. So basically we are back inside the controller, and the controller needs to tell the view something, and it needs to tell the view the score and the hand. So present something like this maybe. So we need to send something also here. So we need to ask the dealer. And we need to, so we can kind of like do it like this. Hand equals get hand. So something like this. So the controller asks the dealer to get access to the hand, and it gives this then to the view to present. So let's get back to the code. A view present dealer hand. So we need to have this operation. But what should we return? The idea of having two player classes is actually that in the model we have a player concept, the player class to manage the player's cards and stuff like that. It's in the domain model. We have a player also in the controller because that represents the actor player that plays the game. So this one is for the rules of the game, the player inside the model, and the player in the controller is for representing the actor player. So, but what should we return? What return type should this be? List. We have some options. We could, of course, just write, well, something like that would work perfectly fine. What would be bad about this solution? Yeah, we kind of like break encapsulation, and we also give the user of the dealer class the opportunity to do a lot of strange stuff with the hand. And this makes it hard to know what actually to do if you are to use the dealer class. So if you have something like this, and we have this start game class operation, and I am the implementer of the controller, and I'm supposed to implement this requirement of starting a new game. Should I get the hand of the dealer and start adding cards to it manually, or should I call the start game operation, and that will do it? So I don't really know what to do, and there are several ways to do the same thing. And that is probably not a good idea. So, fortunately, we could just think about it. What is it actually that we want to do with the hand? Well, we want to go through it, and we want to display it in this case. So we don't want to be able to add stuff to the hand or remove stuff from the hand. We just want to iterate it. And fortunately, we have this available in the collection classes of Java. And if you don't have that, you need to kind of like construct this yourself, because showing kind of like the internals of a class to the outside world it's not a good idea. It kind of like breaks one of the fundamentally good stuffs about object orientation, and that is encapsulation. And the other thing that is destroyed is abstraction, because you would like to work with on a more abstract level when dealing with the dealer, like starting games and dealing, getting the hand and stuff like that, not get the hand and do detailed operations on that hand. That is something that we use the information expert pattern to let the dealer itself have that responsibility, and we should not allow anyone else to mistakenly or not add that responsibility themselves. So iterator card here is the best choice. And also this is needed inside the player class, of course. So I think time is running out a little bit, but I will add the printout of the cards in the view here. It's not that interesting actually. Iterate over the cards in the hand and just print them out for now. And you can think about one requirement that is left, and that is to calculate the scores of the hand. Where should we put this? This is something that you can think about for tomorrow's lecture. So I will be updating this code a little bit and then add it to GitHub, and you can take a look at it. And I will also update the sequence diagram a little bit to reflect this new functionality. Basically, it will be iterating over the cards and then get color, get value for the hands so that we can print them. Any questions? I can show the sequence diagram again. I don't know how much you can actually see, but maybe I can make it bigger. Oh. Why I use linked list instead of array list? No particular reason. Just both would be fine in this situation. I don't think we need any special requirements that makes us choose one over the other. Just the first one that I kind of like saw, so that's why. Otherwise, you could think about performance, and I guess that that getting indexed primitives in an array list is a little bit faster than in a linked list. Linked lists are often better to just use the head or the tail of the list. So if you have a lot of data that needs to be handled in some way, you need to think about these choices. In this case, you don't. Yeah, the syntax is looks something like this. And as always with tools, you need to kind of like work with them, and they are not always perfect UML, but it can be close enough for most parts. So I think the main idea is to use the sequence diagrams as a tool to kind of like understand what you actually need to do in your requirement and map this to the design and to the classes. As I said some lectures ago, I personally don't do sequence diagrams first, and maybe this kind of like also showed during this lecture that I coded a little bit, and then I need to go back to the sequence diagrams and add a little bit, and sometimes I did the opposite. I did the sequence diagram first and then did code. The exact order is not written in stone, and we have actually not done a class diagram yet, so that will probably be done tomorrow when we have this first kind of like requirement in place. So the exact order of implementation, design, and testing a little bit is somewhat floating. Of course, depending on your project and stuff like that. In this case, we don't have that many classes yet, so it can kind of like be in the head of us as we do this. In something that is more complicated and larger, well, then maybe we need to have the class diagram up when we do this sequence diagram also, and maybe if we are a lot of developers, we need to kind of like at least coordinate our efforts for the day and maybe take a look at the design at our stand-up meeting or what we do to start off the day, and divide work and discuss how certain aspects are going to look in the design, and then go off, implement, maybe get together again to redesign or solve other problems and implement some more, test some more. So the exact order of things is not written in stone. Any other questions? I guess you mean for grade 3 and 4 in workshop number 2. So, adding a simple method for searching a member by name is not enough. You should use a design pattern to solve the problem of searching, and it should be easy to add new criteria. So searching by name is just one of possibly several different types of searching you could do. So the main idea is to do a design that makes it easy to add new ways to search in this member registry. And easy is often defined as you should not need to change in too many places if you add this new functionality. So you should be able to add functionality without needing to change the application in classes that already exist, or as few places as possible in these classes that already exist. The exact design of it is, of course, part of the task, so I won't tell you exactly how to do. Yeah, if you submit for grade 3 or 4 for some of the workshop, that is done towards the end of the course, as you probably have seen. And if you have some minor errors or stuff like that, I will send you an email and ask you to think about some stuff, and you will get a new deadline to make changes for that and resubmit your solution. So one search function is enough. Yeah, depending on your design, but it should be easy to add new search criteria. So if I would like to add a search criteria for boats that are over a certain size, it should be easy for me to add that. Yeah, the design should absolutely show how these new searches are added in an easy way. And the best way to do that is, of course, to implement one or two of these, and so I can see how adding a new one would be done. All right. That's it for now. So think about the where to add the responsibility to calculate the score of a hand. For tomorrow, I will do some minor updates for now and add the code to GitHub, so you can take a look at it. We'll do some minor adjustments to the sequence diagram also, I think. All right. I think that's